Oh, let me pause this real quick. Pause. So these aren't really notes. What this is we're just going to kind of work some problems together off of this assignment. So you can see at the top of it, this is assignment number 52. Today is March 10th. By the way, Monday is Pi Day. You know, the 314 thing. So if you guys want to bring pies on Monday, you're totally welcome to. Some kids are really into that and they will bring a pie. Some kids will even bring 2 pies. It's up to you, but Monday is 314. And if you wanted to bring pies, that wouldn't be what we do all day. It would just be, yay, we can have a slice of pie. So you can bake a pie, you can get a store-bought pie, you can bring no pie. I just want you to know that even though I won't participate in eating the pie, I just want you to know that you can take advantage of the date and bring a pie if you are into that thing, you know. So whatever, it's up to you. Yeah, so today's March 10th, and we're just gonna basically, I'm only recording this for the sake of, I realized first hour that I should have. So we're just gonna work some selected problems from assignment number 52. And I'm gonna stick to the same problems that I chose. I'm going to run through them first, and then I might go back and do a couple of others. So bear in mind as we do this, that we are working to an end game, and that is getting your assignment done. So rather than like notes and then we're starting together right now. So we're going to start with problem number 3. And it's procedurally, it's nothing you don't know how to do. The only reason I am adding this one in here, I'm switching it up, is because something happens at the end of this problem that I think is worth discussion. So problem 3 is just a simple log. You've already taken a quiz over this format of an equation. It's just ready to water cycle. So you should all see log base 3 of x squared plus 1 equals 4. So if you water cycle that out, because that's what we do, right? When we have log equals a number, what would it say? Right, so we would water cycle it out and get 3 to the 4th power equals x squared plus 1. And I realize fully that a lot of you, instead of writing 3 to the 4th, might have just written 81, and that's fine too. So this is a quadratic equation, and what we're generally accustomed to with quadratic equations, if I'm doing my job well, eventually I get this idea stuck in your head that quadratics should always be set equal to 0. The trouble with that is there are exceptions, and not all quadratics should be treated quite exactly the same. So there's a better way to solve this one, and it's not factoring. So hopefully you remember this from some time in the past. I'm going to leave the x squared on the right side, and I'm going to subtract 1 from both sides, which gives me this. Now, off to the side here in yellow, I'm going to write some problems that are similar to this, just so you can get on board with what we're about to do. If I gave you something like x squared equals 4, and I think you'll actually see this one later in the assignment, would you all agree that the answers are x equals positive or negative 2? Because both of those numbers, when squared, equal 4, right? Or if I gave you another one that was, again, pretty easy, I think, to do mentally, if x squared is 100, what's x? Positive or negative 10. If I gave you, I could keep going, right? But the thing is, if the number is what we call a perfect square, then taking the square root of it is super easy. I have to take this real quick, sorry. So again, if I ask you to take the square root of a square, it's easy, you just get a whole number, but kind of a blast from the past here. If I take the square root of that blue equation on both sides, I wind up with x equals positive or negative square root of 80. This is not an appropriate time to use a decimal, because what happens when you try to take the square root of 80? What kind of decimal do you get? An irrational one that literally by definition will never end, it will never repeat. And those are the decimals that we tend to want to stay away from. And so in a case like this, we're going to leave it as a root, but here comes a way big blast from the past. You guys remember how we attack square roots like this? It's a tree. You guys remember the tree? It's been a long time. We use this a lot when we did our unit on quadratics, like the quadratic formula, but what 2 numbers can I break the square root of 80 into? Very good, quick answer. 16 and 5. And there is no other acceptable version of this. I don't want to hear 4 times 20 because then that's going to take multiple steps. So 16 and 5 is our go-to. So in the simplified down version of number 3, our answer would at the end be x equals positive negative 4 root 5, like that. There's going to be a problem, like I actually think it's number 5, and I'm not going to do it with you, but problem 5 is actually going to come out as a decimal, and I'm fine with that particular decimal because it's a rational, like an ending, terminating, friendly decimal. But if you learn a few things from me, let that be one of them. Long, unending decimals are not to be messed with. Let's talk about number 7 after this. Number 7 is something new, and honestly, if it hadn't been for these, I might have just handed out this worksheet today and said, good luck, suckers. So I realized that this is a type of log equation that we have not yet seen. This is a log on the left, something we've not seen before, equal to a log on the right. This is a new flavor of problem. And there is, by the way, a workaround. If I wanted to teach you this the harder way, I could teach you that we could pull the logs onto the same side, and then we could condense them, set it equal to 0, and then water cycle it. But there's actually a huge bit of common sense at play here. And it's something that at some point, it's a bridge we needed to cross, so I'm glad we get to cross it today. If I told you that I had a log with a base of a and an argument of b, and then I had another log on the other side of an equal sign, also with a base of a, but an argument of c. I realize there's a few of you in this room who are ready to say the answer to this, but I'd like kind of all of you on board. If this statement is true, what else has to be true? Go ahead, Xavier. Yes, and it's irrefutably sensible to say that. If log base a of b is equivalent to log base a of c, there is just no way around the fact that b has got to equal c. The entire system of mathematics wouldn't even make sense if that weren't true. Having said that, when I look at problem 7 and a whole bunch of other problems, by the way, this applies to problems all the way 7 through 14. If I have a log base 19 of the red box equal to the log base 19 of the yellow box, then I hope if things have gone well in the last minute or so that you agree that what's in the red box must equal what's in the yellow box. And if you think about it, it's honestly something we probably could have pieced together on our own, because in the same way that you can log both sides of an equation, you can unlog both sides of an equation, or it goes both ways. And that's really all we did. And then it goes instantly from an 11th grade math problem to like a 7th grade math problem, because now it's just what we call a linear equation. So I would, of course, subtract 2n from both sides, giving me 1n. I would add 10 to both sides, giving me 12. And I'm not quite ready to put a box around that yet, because remember, we're in the world of logarithms, and we always want to make sure that our answers do not make logs with negative arguments. So at this point, 12 isn't so much the answer as he is a candidate. And so quickly, you don't need to show work on this. If you take 12 and put it into the first log, what's 2 times 12 plus 2 is obviously 26, right? We're good. And then if you put 12 into the other one, 3 times 12 minus 10 is also positive 26. And so now I can say I'm ready to commit to giving you a box. You are my answer. Had you not worked, we were in no solution. If your only candidate fails, that's the conclusion that you arrive at. All right, after that, let's take a look at problem 11. And problem 11 says that we have a log with a base of 8 on the left side equal to a log with a base of 8 on the right side. So rather than me having to copy the problem down, what has to be true? Right, the arguments of the logs have to equal each other, don't they? And so in this case, specifically, that means that b squared plus 20, by definition, has to equal negative 11b plus 2. We agree? Okay. Now this is not a 7th grade equation, and I realize I need to do a better job as I go through this class in particular, Algebra 2, of making sure you guys understand the difference between a quadratic equation and a linear equation. Linear equations we did in 7th and 8th grade, and for most of Algebra 1. That's where we segregate. That's where we put the x's on one side and the numbers on the other side, and then we divide to get the variable by itself. What do we do with quadratics? Yes, you set them equal to 0. Thank you for that. And that, I hope you take that away from this class, that a quadratic equation is not necessarily to be treated. I shouldn't even say necessarily. It's not to be treated like a linear equation. So I'm going to leave b squared where he is. I'm going to add the 11b across. I'm going to subtract the 2, and I'm going to set it equal to 0. Right, and then it's time for the F word, factor. So we have b plus 2 times b plus 9. I also noticed that some of you guys, if you would look up here, some of you guys tend to not write equals 0. I need you to not do that. I need you to keep putting equals 0. That's kind of the glue that holds all of this together. If it doesn't equal 0, we're wasting our time. And so what are the answers then that we get? And so it's our responsibility now to vet those and say, like, are you okay? Do you work? And so going back up into the logarithms, I'm not concerned with the first logarithm because it says b squared plus 20. There is no way around the fact that when you square something, it becomes positive, and when you add, it becomes more positive. So both candidates passed the first test with flying colors. I'm mildly concerned. Not even really. I'm only saying that, but I'm maybe mildly concerned with the second one only because I don't have that square thing. But like if I put -2 in place of b, what's -11 times -2? Just positive something, right? And then look at the other one. What's -11 times -9? Positive something. And so if you take positive and a positive, these both pass the test, right? Do we agree? Mm-hmm. So again, that is always our responsibility, is to check them and make sure that they work. All right, let's talk next about number 13. Excuse me, number 15, I apologize. 15. This is something that's kind of already from your past, so I don't actually know why we chose this one first hour, but it works. So I'll kind of go and hold here for a moment and wait while you guys come to consensus. What do we do? That's that C word. Condense. We condense, right? We've seen this before. We've already literally taken a quiz over this. And so if on the left side you have 2 logs added together, you want to condense them into a single log so that you can do the water cycle diagram. And so on the left side, because there's a plus sign in between the 2 logs, it's going to condense into a single log with a base of 3. And what will its argument be? X squared. That's what everyone always wants to say, but it is definitely x squared plus 6x. And that's, if I multiply the arguments of the 2 logs together, the x from the second log has to distribute itself through, right? Any questions on that so far? I like this worksheet because it's like a bunch of different flavors kind of packaged into one place. And then from here, what would we do? It's actually the worst thing you could do. Yeah, water cycle that thing. As soon as you get to the point where you got log equals a number, it's always going to be the right thing to do, is convert it to exponential form, we say. So when we water cycle it out, we get 27 equals x squared plus 6x. Right, and that's got to be our thinking. If it's this normal kind of quadratic where it's got an x squared and a regular x and a number, setting it equal to 0 is your go-to. So we're going to leave the x squared where it is. Remember, our decision is never based on an affinity for the left or right side. It's based on where you're going to be positive at. So I subtract 27, and then it's time to factor. And that ought to be pretty easy factoring, I'm thinking. I'm hoping. What is it? Good factoring. Well done. X plus 9 times x minus 3 still equals 0. Therefore, my candidates are right. And let's check them. And so go back to your original problem, and up right out of the gate, -9 fails miserably. He gives us the log of -3, which by definition is undefined. So we'll take -9 and say, thank you, but your services are not needed here. And then we got to try 3. And I don't think we have any issues with that, do we? We get log of 9 and log of 3. So he passes and we're fine. So 3 gets a box, -9 gets a cross out. The last one that we did together was 21. They chose that, and I thought it turned out to be a pretty good choice. I'm going to wrap this up after we do this problem, but just kind of so you guys know who are in the room here today that there's going to be some other sorts of things, little eventualities, things that pop up, and just ask about those kind of in the moment, and we'll talk about. I don't want to do every problem with you, but I also know that you'll get some questions where you go, oh, what's this all about? And we'll talk about it. So for question 21, you've never seen a problem like this before. So this is like a hybrid of a lot of different, the multiple things that we've already talked about here today. What are you thinking first? Oh God, yes, what a great answer. I see 2 logs right next to each other with a minus in between them. That's a golden answer. Let's condense them. Well done, Logan. We're going to have log base 9 of x minus 3 over x is equal to log base 9 of 63. Good, excellent, good thinking. Just top notch there. 2 logs next to each other, condense them into 1. What now? I think I know. Words are hard. In the same way that we can log both sides, we can unlog both sides. You can say drop the log. Some people laugh when you say it. It doesn't matter. But bottom line is the logs can go away because log base 9 of this equals log base 9 of that. This has to equal that. So we wind up with x minus 3 over x equal to 63 because the logs just go poof. You clear on that, right? We would multiply both sides by x now. So now we're just back into normal algebra, no logs, no water cycles, just solving an equation. So if you multiply both sides by x, then on the left side, you wind up with these x's canceling out, and you get x minus 3 equals 63x. And this is not a quadratic equation. So if I said, what do we do? And you said something like set it equal to 0, then I'd have to cloud up and rain on you because that's not how we approach linear equations. Our thinking here is to get the x's on one side, the numbers on the other, and then divide as necessary. So I'm going to, yeah, we're going to move this x to subtract both sides would be just fine. Or again, just if you're to the point where you just say move it over, just move it over. Just don't do anything stupid and say something like 64x, because them's fighting words right there, right? And so we're left with -3 still on the left, 62x is on the right. And then what do we do to finish the job? Divide by 62. Which gives us an answer that's pretty uncomfortable. If you were to try to divide that on a calculator, I don't know. The point, I guess, it doesn't really matter because let's talk about this. If you take that answer or that candidate and put it right away, boom, right away in number 21 in the first log, what do you know? You don't have to be a math whiz. And if you're turning this into like, oh, I got to find a common denominator, oh, knock it off. It ain't going to work. If you put a negative number in place of x and then you take away 3 more, is there any escaping the fact that it's going to be a negative something? No, I don't care what it equals. I just know it's going to be a negative, and therefore, by definition, it does not work. And therefore, by definition, we say that there is no solution. As we've seen before, if the only candidate we have doesn't work, well, then I guess we're going to go without. So the rest of the hour will be yours to work. I think I covered a little bit more than I did first hour, but I'm sure, again, like I said, there's more. So just ask when you get there, whatever you find.